Okay. Hi, we are back. Okay, so let's continue on. All right. I had very good sleep, so my voice is doing just fine. And we are doing this back-to-back episode, but yeah, voice is doing just fine. All right. So sleep is about healing, recovering, repairing the worn out, damaged body parts, including the vocal cord, So yeah, weekend sleep is good for health. Nap, long nap, whatever. All right, so where are we? Infinity algebra. Okay, so it's this. Okay, so e to y is equal to e to the x. Okay, it kind of is representative of all the exponential function, including 1.1 to the x, 2 to the x, 3 to the x, as long as this guy, this you have exponent and below number. I don't know how they call it. Okay, maybe base of this. Y is equal to e power x. Okay, if you switch that, y is equal to x to the e, which is equal x to the 2.73 blah blah blah, right? Then it becomes a polynomial. Okay, if you switch around, then it becomes an exponential function. Okay, so as a general rule, all right, it's like this. You have y is equal to x, y is equal y is equal to sorry, messing it up. Y is equal to x plus 2. Y is equal to 2 times x. Y is equal to x to the second. Next step, yeah, y is equal to 2 to the x. Okay? Well, okay, you have also what? In terms of this power operation, inverse function of that is y is equal to square root of x. Inverse function of that is y is equal to logarithm of base 2 of x. Okay? And it's easier to say 2 to e to the x and ln x. That's base e, Euler's number, which is like 2.7 something. Okay? You got it? Am I moving too fast? Then you need to catch up, alright? It's not that hard. It's just plain old calculus, okay? Or just mathematics. We are not differentiating anything. We just find the inverse function theory, alright? So, yeah, it's just operators. So, up to here is what traditional mathematics is dealing with. But we don't have to stop here, though, okay? So, you have what? For example, next level will be this 2 to the 2 to the 2 to the 2. We can call it 2 top 4, all right? Because there are 4 of them. Okay, it's a generalized operation theory that we talked about. I think we talked about this like long time ago, or over multiple occasions. We don't have to stop here either. 2 top, 2 top, 2 top, 2. We can call it 2 left shoulder 4. All right? And how about 2 left shoulder 2, left shoulder 2, left shoulder 2. Okay? We can call it 2 left foot 4. How about 2 left foot 2 left foot 2 left foot 2 is equal to what? 2 right foot 4. Then we run out of space, right? So yeah, it's a generalized. We can just call this as a plus 2 plus 4 n. Okay, it's the concept of generalized addition, generalized operator. All right. So plus to the first is just plus. Plus to the second is multiplication. Plus to the third is power. Plus to the fourth is the top. Plus to the fifth is the left shoulder. Plus to the sixth is the left foot. Plus to the seven is the right foot. Okay, so yeah, it can go on, and from plus to the third, like power operation. Wait. Yeah, plus first, second is addition and multiplication. Plus to the third is power operation. From then on, it bifurcates. The inverse function bifurcates into two. Why? Because it's not commutative. A plus b is equal to b plus a. So they have only one inverse function. What is it? I mean, inverse operator. What is it? Yeah, subtraction. A times b is equal to b times a. So they only have one inverse operator. What is it? Division. Okay? But a to the b is not equal to b to the a. That's why they have two inverse functions, inverse operators. One of them is radical, like root of something. The other one, logarithm. Okay? Yeah, we can define that on and on for each dimension of this operator. Okay? It always bifurcates. Okay? Inverse function. All right? So that's what this is. And we talked about inverse operator and inverse function, and well, let's see. Y is what? X plus 1. Okay? Okay? What's the inverse function of that? Well, to find inverse function, you switch x and y. Okay? So x is equal to y plus 1. So y is equal to x minus 1. Yeah, they're inverse function to each other. Plus and minus, okay? Because they are symmetric, they are mirror reflection against this y is equal to x. Yeah, you have mirror image. Let's say this y is equal to x, this diagonal line that passed through this 0, 0. Okay? It's a mirror. And you are u, y, u. Your x, y is equal to x plus 1. The mirror image behind this mirror, reflective mirror of this diagonal line, y is equal to x. Yeah, that's y is equal to x minus 1. Okay? 1 minus 1, okay? Let me get some wine. I mean, not wine, but vodka. Okay, because wine, it doesn't do the job. I need vodka. I need something strong. Beer, wine is only when I'm having this heartburn in my esophagus. But I took a long nap, so I don't have any heartburn because it's all repaired. Okay, let's erase all this. We do multiplication, okay? Y is equal to 2 times x, all right? It's inverse of that, okay? X is equal to what? 2 times y, so y is equal to what? X over 2, right? Let's see if it makes sense. Yeah, you have this diagonal mirror, y is equal to x, right? Y is equal to 2x, it looks like this. Steeper. Y is equal to half of x is like this. So yeah, that mirror reflection, mirror image. Okay? It's like folding, okay? You have this folding line. You fold in half along this line, diagonal line, and they become the same thing. Y is equal to 2x and y is equal to x over 2. Okay? Whew. Boy. Next step. We're talking about symmetry in mathematical operation. Alright? So, alright. Well, this red pen is running out, so I'm gonna use brown pen. You have y is equal to x squared, okay? Like this. Parabola, right? And you have this y is equal to x, okay? Now, you switch x and y, right? So x is equal to y squared. So y is equal to plus minus square root of x, right? It's like this. Mirror reflection. Okay, x and y, okay? Yeah, this is y is equal to square root of x. This is y is equal to minus square root of x, which themselves are mirror reflection along this horizontal axis. Okay? So that's that. I know I'm going very fast. We have to, okay? It's very elementary stuff that you learn in, I don't know, middle school, elementary school. I don't know what they're teaching in schools nowadays. But back in the days when I was in South Korea in 1980s and 1990s, we learned this in middle school, like 7th grade. Okay? Alright, now, next step. Y is equal to 2 to the x. Okay? Goes like this. You have 1 exponential function. Okay? And of course you have y is equal to x as a mirror. Now, switch x and y. X is equal to 2 to the y is equal to logarithm base 2 and of x. Okay, so it goes like this. So you have 1, yeah. Okay? So you have y is equal to 2 to the x, y is equal to x, and you have y is equal to logarithm 2 of x, okay? And that's all this mathematics, in mathematics history, they don't go beyond this. We don't have to limit ourselves like that. Okay? Because we can think of an equation like y is equal to 2 top x, okay? And y is equal to some funky logarithm, whatever, okay? So, But before we do that, let's you have yeah, you can do that later, okay? Later. Two top x, two left shoulder x, and two different kinds of inverse function of that, okay? So we have that, and then we have y is equal to what? Square root of x, right? Y is equal to, x squared, okay? And you have y is equal to square root of x, okay? So y is let's compare these two guys, okay? Y is equal to square root of x. Y is equal to x squared, and y is equal to 2 to the x, okay? Initially, yeah, y is equal to 2 to the x was higher than y is equal to x squared. But later on, so this guy, y is equal to, you know, you got it, okay? So we're gonna highlight only two guys here. And we're gonna, for convenience sake, we'll do e to the x, okay? Y is equal to e to the x, okay? 2 to the x, okay? Then you have y is equal to x squared, okay? Eventually this guy will catch up. So here, from here to here, what is it? So x squared is equal to 2 to the x, right? What is x? I don't know, man. What is this point? Your y is equal to x squared and y is equal to 2x, okay? Okay, so x is equal to logarithm base 2 x squared, which is 2 times logarithm base 2x, okay? So x over 2 is equal to logarithm 2x, so x is equal to 2 to the x over 2, which is equal to 2 to the x 1 over 2, okay? So they get multiplication, okay? So oh boy. You know, my mathematics very rusty and clunky, okay, because it's been a long time. What the hell is this? Oh boy. Okay. Square root of 2 to the x, okay, so. Alright, so you have x is equal to square root of 2 to the x, so you multiply by x squared is 2 to the x, okay. We come back, we're circling around. What is this number x? I don't know. We can take a guess, okay? If x is equal to 1, okay, y1 is x, so yeah, 1 comma 1, okay, so 1 comma 1, and then you have 1 comma 2. So we know this x here, intersection between this y1 and y2 is more than 1. How about number 2? 4, got it. So this is 2. And here you have 4. Okay. That's the first solution. But there is another intersection because y is equal to 2 to the x, it will eventually catch up again. So between 0 and 2, yeah, 2 to the x wins. But between 2 and something, we call it k, this parabola is bigger than exponential. But in point k, which is I think will be a very big number, yeah, there is another intersection because exponential function eventually catches up again. Okay, so we want to find that k. Okay. All right, let me draw another diagram and then we'll take a break. Okay, so boy, anyway, it's running out, so this is running out too. First parabola, okay. Then we have something like that, okay. I'm cheating a little bit. So between here 0 and 2, okay, e to the x was bigger than x squared. Between here and here, 2 and k, yeah, e to the x was smaller than x to the x squared. But from k to infinity, okay, e to the x is again regain the power. It's like, okay, x squared, this guy is a kind of rebel, stupid rebel. So e to the x is the real heir to the throne, the prince, like Solomon, okay? But after a while, this stupid ass son of David, King David, yeah, he took over the throne. But in the end, yeah, Solomon took it back. Recovery, okay? Because Solomon is like exponential function, and this shit ass son of another son of David, Solomon's brother, he's no match for King Solomon, we want to find the second intersection. I don't know how to do it, okay? So, well, it's not E. Well, it could be E, but in this example, it's 2, okay? So, I will have to look it up in the internet, like Stack Exchange or something. Because I don't know how to solve this equation. It has 2 solutions, okay? There's only, yeah, well, technically, yeah, you have 3 solutions, right? Because it's a parabola, right? What is this guy? Yeah, obvious. It's not that obvious actually, because e to the x, it's not symmetric function, so it probably won't be -2. Probably something, maybe there's -2 here, maybe it's like -1.3, whatever, okay, I don't know. Minus 0.5, whatever. We are trying to solve this equation, x squared is equal to 2 to the x. And there has to be 3 axes, 3 intersection. Here, 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 okay? I don't know how to solve this. Do you? If you're a mathematics major, maybe you do. I don't know how to solve this, okay? It's an equation and there are three solutions to this. All right, so you have parabola here, okay? This parabola. And then you have exponential function. Exponential function that goes like this. Okay? Yeah, so there has to be three intersections. Three intersections. Three intersections. Okay? I'm a Korean English speaker, so we are not very good at plural making. Because in Korean language, we are kind of lax about plural and singular. We don't really distinguish between plural and singular, okay? Kind of community living, like in American natives, community, property, whatever. We are not so picky about plural versus singular. Okay? Yeah, you have parabola and exponential function. I'm sorry, it's kind of like shitty kind of picture, but there has to be three intersection. We found one. The other two, I have no idea. I have to look up in the internet, okay? So we'll take a break, okay? If you know, let me know, okay? Yeah, you can use Newton's method, whatever. I just want to find out some approximate value to this. Is it algebraically expressible? In Galois theory, the solution to this equation. Simple equation. X squared is equal to 2 to the x. Is this x algebraically expressible? I don't know. Okay? Maybe it is, maybe it's not. I don't know. We are not dealing with some fifth order, sixth order, seventh order. No, it's just we are dealing with two. We are combining polynomial and exponential function. Okay, so is this x? We know there are three, but are they algebraically expressible? I don't know. I have to look it up. Maybe you can apply Galois theory if you happen to know Galois theory. I don't know. Okay. So let's take a break. Okay. I'm gonna look this up. Okay. But looking up in the internet of this mathematical expression is very tricky. It's not easy. Okay. So yeah, there's the software like latex, text, developed by this Professor Donald Knuth in Stanford, but I don't know anything about that. So we'll take a break, okay? All right. Before I take a break, I need some drinks. So. All right. We are back. Okay. Yeah, I looked up in the internet, of course. So, where's my hat? Nightcap, right here. All right. You cover up my bald spots, so that's good. No need to worry about my bald spot showing it to you. Oh, boy. So yeah, sorry. K turned out to be 4. 4 to the second 16, 2 to the fourth 16. So yeah. But this guy is turned out to be minus 0.77 something. Okay. Yeah, it was minus 0.77 something, okay? 0.9, whatever. Minus 0.7 or minus 0.8, something on in that range, okay? So, this guy is 4. 2, 4 minus 0.7, something like that, okay? Just for fun, okay? So I looked up in the internet, and there's this nice and kind and generous mathematics professor who mentioned this Lambert function. Okay, so we'll go over it. Okay, so let me look up who's this Lambert. Yeah, obviously he's French. Lambert, whatever. I heard his name mentioned before, long time ago. Okay, his name rings the bell. Lambert. Lambert. It's not D'Alembert, but I heard his name mentioned. Okay, he's Swiss, Switzerland kind of guy. Okay, well, whatever. His last name kind of sounds French. Where he's referred to as polymath. Polymath meaning he's multi talented kind of guy in Switzerland. Yeah, Switzerland, they speak multiple languages, don't they? I've been to Switzerland like briefly when I was traveling Europe, second time. Yeah, I've been to Swiss. One thing that really surprised me, I had took the train. It could have been TGV or whatever, Switzerland train, and they have this restroom, and their restroom was so third world. I mean, Switzerland train to go from Switzerland to Germany or France. It's very developed country, but their restroom was so third world, like developing country. They have this. So I went to restaurant in this train, international train between Switzerland and France, whatever, and they have this open bottom. So if I poop down or pee down, it just goes straight to this ground in this train track. I was shocked. Oh my goodness. What are you thinking? It's a legit major train, and you just let us poop on the ground because I looked down before I pooped and peed. It's just open. This is a train track. Why do you do that? It was a shocker. I'm not making this up, okay? So this Switzerland train, latrine, this. It was shocking, okay? So I'm almost being tempted to look it up, okay? Let me look it up. Switzerland train, pooping on the train track. My goodness. I don't know what kind of train I took in Switzerland, but it was legit official mainstream train. But I look down, it's just like this outside this train track. So if I poop, I'm pooping on the train. It straight go down off the train to this ground, the nature train track. So along all this train track, there are human feces because it was like open. I can look down and I can see this train tracks. Okay, they just have this hole between the train bus and this raw ground train trail. So if I poop and pee, it just accumulates on this train trail. I was shocked. So that was my experience with Switzerland. Strange. Whatever. Okay, let's continue to read this Lambert. Okay. Swiss, strange land, really. Strange country. Okay. I don't know how to pronounce this in Switzerland because Swiss they are multilingual. Okay, it's a fantastic country, like politically neutral, multi-ethnic, whatever. Okay, it's kind of Switzerland. Okay, they speak multiple languages there. Polyglots. If you are Swiss person, yeah, you speak French, Deutschland, whatever, German and English, probably Italian. So, Johann Heinrich Lambert, okay, because they speak French and they speak German. Swiss polymath, mathematics, philosophy, physics, astronomy. Langberg, okay? His first name and middle name sounds like German, you know, but his last name is French. That's classical Swiss. What was his job? Well, he got some odd job when he was young. Okay, this mathematician, Switzerland, mathematician, as a tailor, tutor, this masonry editor, Basler Times, Basler Times, Basler Zeitung. Okay. He worked in Prussia, befriended Euler. He died kind of young. He died at the age of 49. Okay, so Langberg. So he was the first to introduce hyperbolic function into trigonometry. Okay, okay. So he first proved that pi is irrational. Okay, smart guy. So he made a conjecture that he proved that pi is an irrational number. Okay, so okay, whatever. It was first proof that pi is irrational. That's big. Okay, this is a Langberg. Okay. So Langberg achieved something that Euler, the great mathematician Euler, could not even prove. Okay, but Langberg he proved that. So, in a sense, he was better than Euler. Okay, so okay, hyperbolic function. So yeah, we were wondering about this hyperbolic function that has this Euler's number like e to the x plus e to the minus x that's equal to I divide by 2 is the hyperbolic function sine whatever, okay, or is it minus, yeah, cosine is plus, sine hyperbolic sine is minus, right, something like that. Yeah, so it's Langberg, okay. I will tell you why I got into Langberg later. Okay, so yeah, sine hyperbolic is like e to the x minus, I think it's minus, okay, over 2, and cosine hyperbolic x is like e to the x plus e to the minus x over 2, okay? Yeah, so sine hyperbolic differentiated is equal to cosine h hyperbolic x differentiated, okay? Yeah. So it kind of behave as if they are trigonometric function. Maybe that's where Mr. Lambert connected this, you know, tangent bridge, low hanging, relaxed string to this trigonometry. And cosine of hyperbolic x differentiated that is equal to what? Sine hyperbolic x. Okay, let me see whether this is correct or not, because I'm known to make a lot of errors and mistakes, so I gotta look it up. Hyperbolic stuff. It behave very much like trigonometry. Okay, so yeah, yeah, yeah. Okay, so it's correct. Okay, I didn't make any mistake here. Okay, so. Because in trigonometry, sine x differentiated is cosine x, but cosine x differentiated is minus sine x. Okay, so yeah, there's some difference, but it's similar enough. Okay, so this is minus sign here. Okay, so cosine x differentiated twice is equal to minus sine x differentiated is minus cosine x. Okay, so cosine x differentiated 3 times is equal to cosine x. Okay, and sine x differentiated second time is what? Minus sine x. Okay, it almost looks like sin. Oh, I'm guilty. You know, I committed some bad, dirty deeds. Whatever. You fool me twice. Shame on me. You fool me once, shame on you, boy. You fool me twice, shame on me, okay? Oh boy. You're trying to connect mathematics and humanology. Okay. Sin. You fool me twice, shame on me. You fool me once, shame on you, okay? You become cosine, whatever. It's a mathematical joke, humanological joke, okay? I think it's a good time to take a break, okay? So why don't you mule on this, okay? We get back to Lambert. Museum Lambert, or Herr Johann Heinrich Lambert. Okay? Alright? Yeah, take a break. Take 5. Man, what the fuck are we doing? Oh boy. Ah. Okay, we're back. Um, I ran out of milk, which, which doesn't really panic me. If when I ran out of cigarette or when I run out of vodka, yeah, I panic. Okay, but when I run out of milk, no big deal. All right, so okay, so let's continue reading this Langbear biography in Wikipedia. Okay, so I gotta turn on the heater because I'm getting cold now. I got it. I caught it. Okay, I caught it before it collapsed. Give me some credit for that. To compensate for my earlier fuck ups of this what second Lupita. Ah, all right, Langbear. There's also mathematician called D'Alembert. Okay, I'm not sure if they are related. Maybe distant. We are related to Adam and Eve, whatever. So Langbear. Okay, conic section. All right. So I remember back in the days when I was in South Korea in high school. Yeah, I read a lot of. I had books about the history of mathematics, the story of mathematicians in Europe. Some of them in China, in Middle East or India. Okay, but mostly Europeans. Okay, yeah, I had many books about that because my parents they are so kind and generous to let me buy these mathematics books because Korean parents, yeah, they are very about a lot about education. So they tend to not spare any money buying books. Okay, so yeah, my parents they're Middle East. I mean middle class, not Middle East, but middle class. Okay, so yeah, they allowed me to buy those books, mathematics, history. Okay, it was not required for me to purchase for schoolwork. Yeah, I would go to bookstores and, hey, mom, dad, can I buy this mathematics history book? And yeah, they let me. Okay, so God bless them. Okay, so Langbear, I remember seeing him. His picture, his name, I remember that. Yeah. Okay, so Langbear, Monsieur Langbear, he communicated with Immanuel Kant. And Euler, the mighty, almighty Euler, and whatever. Okay. Yeah, he's not very famous, Langberg. Okay, but he has this Langberg W function. Okay. Okay. Well, let's get to it. All right. We've been shenaniganing. We've been bullshitting all this time. So okay. So this kind and generous mathematics professor in this online, it's not Wikipedia, but it's some online forum about mathematics. Probably he volunteered, I think. Yeah, a lot of professors, they're so nice and kind and generous. They volunteer for people like me or you who's kind of clueless. They want to help out. Okay, all the programmers in Stack Exchange, yeah, they volunteer to help out stupid dumb fucking programmers like me. Okay, so Stack Exchange is a very cool website, by the way, and all other websites too. All these online forums. We have this brand new tool, internet. Okay, so yeah, free sharing. Sharing of knowledge, just like this King Solomon said. Yeah, knowledge is yelling out on the streets. Yeah, get knowledge for free. Okay, that's the internet. All right, so or public library. Yeah, knowledge is free. Okay, so okay, so x squared is equal to 2 to the x, right? Um, I have no idea. So we said that e to the ln x is equal to x. We didn't quite explore this. I mean, I didn't quite show you how you can derive this. Okay, so I will show it to you now. So 2 to the logarithm 2 of x, let's say, is equal to y. Okay, so then logarithm 2 to the x is equal to logarithm of 2 to the y. Okay, so x has to be equal to y. Okay, that's why is equal to x, meaning 2 to the logarithm 2 and 2, they it kind of cancels out. It becomes x. Okay, so e to the ln is one of those days you're gonna ask me too much. Okay, so ln x is nothing but logarithm e to the x. Okay, all right. What is e? E is Euler's number. It's like 2.73 blah 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 blah. Okay, and this Monsieur Langberg, he proved that it's irrational number. No, he proved that pi is irrational number. Okay, Euler, I guess he proved that it's irrational number. Whatever, but Monsieur Langberg and Euler, I guess he's German, so what? Herr Euler and Monsieur Langberg, they kind of communicate with each other. They're friends, okay? Acquaintances, at least. Whatever, okay? So that's that, okay? So, Langberg function is Langberg W function, okay? So let's say y is equal to x times e to the x, okay? Langberg function is inverse function of this. Let's say this is f of x, okay? Inverse function of this guy, that's defined as this Langberg W function, okay? So that's what it is. And probably it's not algebraically expressible, okay? Yeah, go ahead and explore Galois theory, and maybe you can prove that it's not algebraically expressible, whatever. Okay. This is line bear function. Okay. But I have to go back to this online website in my cell phone, and it's getting too hot, so I gotta turn off the heater and I cook my dinner. Getting late. Yeah, I'm cooking my dinner. Okay, I gotta eat. Okay. All right. So let's go back to basic. I don't want to skip too many things. Okay. I explained to you something very basic in mathematics. Let's say 2 to the 3 is what? 8, right? Okay. Logarithm, all right? So let's say 2 to the x is equal to 5 instead. Okay, it's a notational convention. We write x is equal to logarithm base 2 of 5, which is equal to so x is between 2 and 3. Okay, 2.3 something. Okay, whatever, I don't know. Okay, it's between 2 and 3, because 2 to the 2 to the second is 4, 2 to the third is 8. Then what would be x? 2 to the x is 5. It's probably a number between 2 and 3. Okay? That's logarithm concept. Okay? And back in the days, 100 years ago, they had this logarithm ruler. Logarithm ruler. Okay? Later on, they came up with this logarithm calculator. Okay? But way back 100, 200 years ago, yeah, engineers used to have this logarithm ruler, this stick with this logarithm scale. Okay, just like back in the days, they had this abacus. Do you have any idea what that means? ABACUS, abacus. Let me look it up so that if I didn't misspell that. Abacus. It's a manual calculator. Okay, manual calculator. Okay, back in the days they used to have that. I know because I'm 40 years old, and I'm also from a developing country, South Korea. Yeah, we're kind of behind. So yeah, they used to have this abacus school. I didn't go there, but Abacus. Yeah, abacus is like manual calculator, okay? So I'm not sure if Eastern or Western or yeah, okay. So I guess it's from Middle East. I'm not sure. Calculating frame. Yeah, it's from China, Europe, Russia, okay. It's both Western and Eastern, okay? So they were used in Europe, China. I'm not sure who first developed this, invented this abacus. I don't know how to use it, but when I grew up in South Korea, yeah, there was this abacus school. They learned that. So there's Mesopotamian, Egyptian, Persian, Greek, and also Chinese. So abacus is both Western and Eastern. Okay. Yeah, it's a manual calculator. Okay, abacus, ABACUS. Okay. All right. Just like that, they have this logarithm, this kind of primitive logarithm ruler. Okay. I I read about it just a little bit. Okay. So later on, they calculate this logarithm with logarithmic calculators, digital. Okay. Yeah, scientific calculators. Okay. So that's that. All right. So now let's say oh boy, my my dinner is ready by now, but well, I don't have milk, so I'm not very looking forward to my dinner. Okay, so 2 to the logarithm 2 to the x. Okay, let's say it's y. Okay, so logarithm 2 to the x is equal to logarithm 2 to the y. So x is equal to y. To me, it was very magical moment when I learned this in high school. Okay, because 2 to the logarithm 2 of x is equal to x itself. So 2 to the logarithm 2, they kind of cancels out and it becomes x. Okay, so that was very cool stuff. Okay, so we go back to this anonymous mathematics professor who explained to us about Langbaer relationship with Langbaer function and whatever. Okay, we go back to that. Okay, so okay. I have Bing, I have Google Chrome, and I have Firefox, Mozilla. Okay, okay. Three different search engines. They are cool. Mm. Yeah, well, you know, my phone is very cheap, okay? So, I have to retype all this shit. To type this mathematical equation and Google search, Bing search, whatever, it's not easy. Nightmare. So x to the second is equal to special characters, man. 2 to the x. It's from this Quora.com. Yeah, they use Newton method, Newton Raphson method, okay, whatever. But this professor can't explain that, plain English. So this professor with mathematics PhD, okay, explained that, okay, x squared, okay, is equal to 2 to the x, alright? So, and then x is equal to 2 to the x over 2, right? And he did minus, okay, x minus 1 is equal to, I don't know why he did that, but, but he did that. So 1 is equal to x times 2 times of minus x over 2. Okay, so I guess he know about this long bear function and he want to take advantage of that. Okay, so and then he did this mathematical acrobatic. Okay, it took me some time to understand what he did, but as a educational experience, okay, so all right, so e to the logarithm e to the ln x, okay, logarithm x ln x e to the ln x, okay, is equal to x, right? E to the ln x is equal to x, and it goes bidirectional. X can be expressed as e to the ln x, okay? That's what he did, okay? So 1 is equal to, well, my green pen is fading, so let's use black pen, okay? Here is some mathematical acrobatics here, okay? He's a mathematics professor, like PhD. I'm not PhD, but I know mathematics more than most of you. So let me bridge the gap. Let me solve as this cross-fiction kind of bridge between you and mathematics professor. Okay, let me solve as bridge between people and God, just like Jesus did. Okay, so all right. Okay. Okay, so my goodness, what did he do is this x times, so x is e to the ln x, okay, so e to the ln 2 times x over 2, okay, that's what it is, okay. We are now running out of space, okay, so oh boy, we'll take a break and we'll get back to this, okay, so because we'll take a break and we get back to this, okay, because this is a lot. All right, so give me a break. I'm playing Jesus here, okay? The bridge between secular people who don't know mathematics and mathematics professor. I'm not mathematics PhD, but I kind of know mathematics. I'm also secular. I'm halfway between mathematics professor and you, secular people. Like Jesus playing between God and people, okay? The bridge, cross, okay? That's what I'm doing. Here's my role model, okay? We take a break, okay? We get back to this, alright? Man's job is 24/7. Friend told me, yeah, man's job is 24/7, okay? So, we'll do this, just that. Okay? we are back. Kind of. Almost. So, I swallowed the water wrong way. Whatever. Okay, so we need, we need some room here. Okay. Ugh. Yeah. Maybe it's a good idea to have some nightcap and scarf. Kind of getting cold. Ugh. Okay. All right, let's erase. Okay, we need some more room here. Okay, so so here you have 1 is equal to x times e to the ln 2 to the minus x over 2. My goodness. It's not that difficult, okay? So 1 is equal to x times e to the, yeah, this power that comes forward, okay? So minus x times minus x over 2 ln 2, okay? Now what? I don't know. Ah, boy. Well, let me go back to my website. Ah, it's in Quora.com. Yeah, fantastic. It's not Wikipedia, okay? It's fantastic. This community website, okay? God bless them. Bing is not doing it right, so I go to Google Chrome. Oh man. Ah, where's my vodka? Ah boy. We have like 1 hour left. My dinner is still cooking, okay? Oh boy. But before dinner, I'd rather have some vodka, okay? I mean, I understand what he wrote there, but to go step by step to make you understand what I do understand, that's take more time, okay? So. Okay, so pain in the ass, dude. Ah, okay, here. So this is equal to x times e to the what? E to the x minus ln 2 over 2, okay? Yeah, it's come from here, okay? And then he substitute very clever, smart professor, right? So, what's his name? Well, I'm not gonna tell you his name, so yeah, well, he's very nice and generous professor. I'm not gonna tell his name, okay? So he's in the eastern coast, okay? He substitutes new letter u is equal to is Quora.com, okay? U is equal to x times minus ln 2 over 2, okay? So yeah. Very smart guy. The professional mathematician. Mathematics professor. PhD, okay? There's something, okay? There's something. So 1 is equal to x times e to the u is equal to x times uh, minus ln 2 over 2. So e to the what? U, right? So, okay, I got that. It took me a long while, okay? So, but I do understand what he was saying at one point. Okay, so. He's going very fast. Oh, my goodness. I need some drink. Once, when I was taking the cigarette break, I understood what he was saying, but now I kind of forgot the train of my thought, the Switzerland train, the latrine, bathroom of this train, going straight through this train track, poo and pee. Oh boy, why did they do that? It's like developing country kind of bathroom in a train in a developed country. I don't know why they did that. Langberg, Switzerland, Swiss train, whatever. Okay, let's step back, okay? Sorry. I got lost, okay? Ah, boy, it's involved. I got lost. Right, so we started as x to the second is equal to what? 2 to the x, right? Alright. So x is equal to 2 or 2 to the x to the x over 2, right? I got that. So x to the minus 1 is equal to 2 to the minus x over 2, okay? We multiply by x in both sides, and it's like x times 2 to the minus x over 2, okay? And this guy is equal to x times, he does this e to the x, okay? E to the ln 2 to the x over 2. That's what he did, okay? Okay? So, you got it? We gotta make some more room. Because we are ghetto, okay? We don't have enough room, so this guy is equal to what? X times e to the ln 2 to the minus x over 2, okay? Is equal to x times, okay? Minus x over 2 ln 2, okay? We're running out of room, so all this is about I forgot what it was. Okay, so but let's move on, okay? So where am I? X times e to the x. Okay, the other side is 1, okay? Ah, boy. You know, maybe I will never get this. Okay, I understand this, but to explain this, it takes more time. I think it's a good time to take a break. Let's take a break, okay? Oh my goodness. Bullshit. We'll take a break, okay? Sunday night and I'm alone. I don't get to have sex. Whatever. What the fuck? I forgot my cell phone, so. Okay, we're back. So why are we doing this? Because there's this fantastic, charitable mathematics PhD professor. Okay, we want to honor his contribution. All right. We do not want to make his contribution go in vain. Okay. We want to honor his charitable act, like honoring our parents kind of thing. Okay, so yeah, that's why we want to publicize his efforts, his labor, charitable acts. Okay, so yeah, I did understand what he was saying. Okay, so you have x squared is equal to 2 to the x. Okay, and this Lambert function, W function, he he connected that here. We want to honor this professor's mathematics PhD. Okay, we want to understand what he was saying. Okay, now I gotta type it all over again. Yeah, Google. Okay, yeah, it still remembers what I saw, what I wrote. All right, let's get back to it. Okay, just label. So x is equal to 2 to the x over 2, okay? And somehow he did this minus operation here. This is very smart, okay? Okay? Multiply by x, okay? So 1 is equal to x times 2 look more like this Lambert equation, alright? And then next step is kind of tricky, okay? E to the ln, okay? 2 to the minus x over 2, okay? I'm struggling still, okay? I understand what he did, but to write it out, well, that's more work. So this is equal to x times e to the minus, I mean, minus x over 2 ln 2, okay? He skipped a couple of steps here, okay? So why did I do that? That's where I'm having some problem here. Okay, so ugh. This mathematics professor smacking my face. Oh boy. Maybe he made a mistake here. Okay, so, he's a mathematics professor, PhD, but he may have made some mistake. Because right. This guy, okay. So we have what 1 is equal to x times 2 to the minus x over 2, okay? So far so good, right? And this is equal to x times e to the ln 2 to the minus x over 2, okay? Such a long work. And this is equal to x parenthesis e to the, yeah, this exponent they come out, okay? X over 2 ln 2, all right? Motherfuckers, they're running out of fucking space again. I'm gonna turn off the fucking heater. I'm getting angry, okay? I'm getting hot. Motherfuckers. When you get a lot of pressure, okay, you get hot. Man. I have this limited space here. Oh boy. It's so stressful. I'm getting pressure from this limited space, like ever pushing me. Oh boy, not fun. Okay, so all right, let's follow this guidance of this professor. Man, we erase this motherfucking shit. So annoying. So this is equal to what? 1 is equal to x times x times e to the, so 1 was equal to 1, okay, or to x times e to 2 to the minus x over 2, okay. So if we do is equal to what? X times e to the ln 2 to the x over 2, okay? So yeah, this minus x over 2, they goes in front of this ln 2, okay? So that's that. Then what? Next step, according to this charitable, kind, and generous professor, okay, is equal to x times e to the x. We revert back to this ln 2, okay? So ln 2 to the minus 1 over 2. We are sending this minus 1 over 2 back there, okay? And that's what? He's asking me too much, man. Ah, boy. Is equal to x times parenthesis e to the x ln he says it's 2 over ln 2 over 2 and minus. That's what he's saying, and I'm not sure that if that's true. Maybe he made a mistake there. I don't know. Because here, what he's saying is, in a nutshell, he's saying 2 to the minus x over 2 is equal to e to the x multiplied by minus ln 2 over 2. Okay, that's what he's saying. 2 ln 2, okay? I'm not sure if that's correct. Maybe he made some error, okay? I don't know. Now I'm getting fucking cold. Motherfucker. Do I have to turn on the fucking heater again? Oh my goodness, motherfucker. Ah. One time I was hot, now I'm getting fucking cold, and I feel so miserable. Is this true? I don't know. This fucking professor said it is. I don't know. We either prove it or disprove it, okay? So it is correct. Okay, this mathematics PhD professor, he got it right. Okay. Yeah, it's just my failing. Okay, I'm kind of slow. I'm slow. Okay, I'm fucking slow, motherfucker. Okay, so yeah, maybe it's better to leave it to professionals, not amateurs like me. Yeah, mathematics professor, they're professionals. They're better than me. Okay, sure, whatever. It is correct. Okay, it took me a long while. Okay, what's next? So he substitute u, okay, u as is equal to this guy, x times minus ln 2 over 2, okay? All right. Then what? So Byzantine, it's like labyrinth, man. He's going too fast. I thought I was going fast sometimes, okay, but there was always bigger fish. Motherfuckers. Why do you have to do that, huh? Okay. I got it. Okay. I got what he was saying. He's skipping a lot of steps. All right. Next step is this. Okay. This guy. You know, mathematics professors. Yeah, they go very fast. Okay. Ah, boy. I'll tell you what this Mr. Professor is saying in Quora.com. Okay. I'm not. I don't want to expose his name because me, I'm a controversial figure. Okay, so I don't want to associate people with me because some people hate me. I don't want my friends to be hated just because you hate me. Okay, many people hate me. I don't want my friends to be hated just because they are my friends. Okay, so that's why I don't mention any of the names of my friends because I don't want my friends to be hated because you hate me. I don't want you to hate my friends, okay? Because they are better than me, okay? If they love me, my friends, it's only because they are charitable, kind people, good Samaritans. You may hate me all you want, but please don't hate my friends and families. They love me only because they are charitable, kind, and generous people. I'm like orphan. Okay. If some people love me, it's not because they are as bad as I am. I know I'm bad. Okay. Maybe you can call me Satan, 666, Antichrist, whatever. You may hate me all you want, but please don't hate my friends and families because they love me only because they are charitable, kind, and generous people. Okay, they don't agree with me. They disagree with me. Okay, no, they don't subscribe to what I believe in. All right, you may hate me. That's fine. I understand, but don't hate my friends and families because they are not like me. They are like you. Okay, my friends and families, they are not anti-gaysts, anti-ultra interracists. No. Just me, okay? You can hate me all you want. I understand. I don't blame you, but don't hate my friends and families because they are not like me. They are like you, okay? They just happen to be charitable and kind and generous. They tolerate me, okay? So, all right. So u is this, okay? U is equal to x times ln minus ln2 over 2, okay? And then what he does is he multiply by this guy, okay? Wait a minute. Did he made a mistake? Maybe he made a mistake here. Okay, I don't know. Well, we multiply this by I'm not sure if he made a mistake here. So 1 is equal to Black pen totally ran out. Whatever. With green pen, okay, so 1 is equal to x times e to the x multiplied by minus ln 2 over 2, okay? All these ghosts, zombies, whatever. Okay. We got that. So we multiply either side by minus ln 2 over 2, okay? Is equal to x times e to the x minus ln 2 over 2 multiply by same thing minus ln 2 over 2, okay? Okay, we got it. But we defined u as x times minus ln 2 over 2. Okay, so this is equal to x times minus ln 2 over 2, that's u, okay? X times minus ln 2 over 2, that's u, okay? So yeah, it is, okay? So yeah, professor, mathematics professor didn't make any mistake. It's just me catching up to him, okay? So this is equal to minus ln 2 over 2, okay? Yeah, leave it to professionals. I'm just amateur, whatever, okay? So okay, so we have this, all right? So it's equal to y is equal to x times e to the x, okay? So what would be the inverse function of that? Well, we that's the Langmuir function. Inverse function of this function, okay? This is fx, okay? All right? Now, what is f inverse function? Is this. Let's say x is equal to y times e to the y, okay? Y is equal to what? It's the inverse function of that. And that's not algebraically expressible. And that's where Langmuir, Langmuir comes in, okay? We call it w of x, okay? Inverse function of that. Inverse function, okay? Yeah, and mathematicians, they don't know, okay? So that's that, right? Okay? So this whole thing about u is w of minus log natural 2 over 2. That's what this is, and we don't know what it is. Okay, but using the Newton-Raphson method, they calculated it as minus 0.7 or not minus 0.8. Okay, so but yeah, we explored this all different branches of mathematics. Okay, so we just satisfy ourselves with that. Okay, yeah. So that's that. Okay, so this charitable, nice, and kind mathematics professor, he did not make any error. It's just me catching up to him. Okay, so that's that. All right. So we're gonna call it a day. Okay, I gotta go back to work. I gotta eat. Okay, my dinner has been already cooked. It's been cooled down. I gotta reheat the microwave. Okay, so all right. Thank you. Bye. Thank you for your patience. Okay, thank you.